made of?
No.
Molecular structures?
No.
So do you have ideas?
As discussed, you can have groups which are either hydrophobic or hydrophilic.
Yeah, and how do you do that?
Techniques just discussed.
Okay, the technique just discussed, yeah. Okay, well. So the first approach you can use is to clean with a surface treatment, so with plasma, sorry, yeah. So if you clean with a plasma, so that's something you were mentioning earlier, yeah. What you're going to do is that you're going to cleave all the things on the surface, and most of the time with the plasma cleaning, plasma treatment, you will make your surface hydrophilic, yeah. So you can start with hydrophobic material. You will always decrease your contact angle if you expose your material to a plasma, yeah. But what is important to know is that the plasma doesn't really give you a permanent change in your surface properties, yeah. As soon as you expose your substrate again to atmospheric conditions, then you will have formation again of another layer on your material, yeah. So what is important, for instance, that if you work with PDMS, yeah, if you want to bond your PDMS to another material, what you're going to do is that you're going to do some plasma treatment, yeah. So this would be the surface of your PDMS. You do an oxidation with plasma, and then you have a surface with a lot of nice cylinder groups, and then with that you can bond your PDMS to another material. But what is also interesting is that your PDMS is hydrophobic, and then you know that if you do this plasma treatment, for a certain period of time your material will be hydrophilic. Yeah? So if you want to put aqueous solution in your PDMS, you're happy to make, for a certain moment, let's say your surface is hydrophilic so that you can easily introduce liquid in your device. Yeah? So that's the first approach. And then if you work with glass, silicone, or activated PDMS, so these are hydrophilic materials, and what do you do to change the surface properties? You will do a siliconization. Yeah? That's what we are discussing. So in terms of siliconization, if you want to make your surface hydrophobic, you're going to use indeed groups which are hydrophobic, and typically what you're going to work with is molecules with an alkyl chain. Yeah? So long chain with CH2, CH2, CH3. Yeah? So that makes your surface more hydrophilic, and the longer the chain, the more hydrophobic your surface. Yeah? And if you want to make your surface even more hydrophobic, you can also use perfluoroalkyl molecules. Yeah? And what does that mean? That all the hydrogen or part of your hydrogen atoms in these alkyl groups are replaced by fluoroatoms. Yeah? Fluoroatoms. Yeah? So something which is widely used, for instance, is if you want to create a hydrophobic surface on silicon or glass, you're going to work with OTS, or octadecyl triethylsilane. So a molecule like that with 18 carbon. Yeah? And then you know that you can create a very hydrophobic surface. Yeah? So if I want to work with gold, gold is hydrophilic, what do I do if I want to make it hydrophobic? So how can I modify my gold surfaces? What is the approach I can use?
Graphite tiles.
Yes? Yeah. So if I want to make my surface hydrophobic, what kind of thiol am I going to use?
Like a fluor change.
Yeah, very good. Yeah. So if I want to modify my gold surfaces, I'm going to work with thiol molecules. Yeah. And then I can make hydrophobic or hydrophilic SAM or surface assembled monolayer. Yeah. And what you see here, so in one case I want to make a surface which is hydrophobic. So again, I take a molecule with an alkyl chain, yeah, and I can take either a thiol or a molecule with a disulfide bond. It's exactly the same. They will interact in the same way with the surface, yeah. And then I can have formation of a very nicely ordered packing, yeah, of my thiol molecules. Yeah. So if I want to make it hydrophobic, then I'm going just to use work with alkyl chains. If I want to make my surface even more hydrophilic, then I'm going to have a molecule with an alcohol group at the end. Yeah? And if I have an alcohol group, then I will have a surface which is highly hydrophilic. Yeah? and I can prove it to you. Yeah. So if I take a control surface of gold without any scion, I have a hydrophilic surface. So my contact angle is 75 degrees. If I take alkyl molecule with 16 carbon, then I can increase my contact angle to 108 degrees. Yeah. And then if I take a molecule with alcohol group here, and mercapto means that I have 11 carbons, yeah, then I can decrease my contact angle because I make my surface even more hydrophilic. Yeah. And here, if I take an alkyl which is with fluoroatoms, yeah, so only with 10 carbons, then I can increase also my contact angle higher than 100 degrees. Yeah? Is that clear? So we take the break now. Yeah?